This is my project on how wireless connections work by Caitlin Ryan. Throughout our lives, we've seen technology evolve, whether it's been through the introduction of smarter phones, modern cars, or different platforms for radio broadcasting. Antennas are a type of sensor that are crucial for wireless signaling and have been incorporated into the circuiting of our devices, instead of having exterior antenna on phones or cars. The introduction of circuits in our class struck my interest for the complexity of our devices, and my curiosity only grew stronger when we began to learn about electromagnetic waves. I wanted to understand how other wave forms other than light are able to travel and carry information from place to place. Also, COVID-19 has increased the use of my technology, so I was determined to understand how the devices and wireless connection that we rely on work. Electromagnetic waves combine electric field and magnetic field. As shown in the red and blue illustration, these fields oscillate perpendicular to each other. The EM spectrum encompasses the types of waves that exist, with decreasing wavelength and increasing frequency as you move from left to right. Cellular data and Wi-Fi fall on the left side of the spectrum under radio waves. However, Wi-Fi is slightly more to the right of data indicated by the figure. This means that the wavelength is smaller and the frequency is larger. This is characterized by the term larger bandwidth, which also describes why Wi-Fi is better for downloads, because more information can travel over a shorter distance. By looking at the figures, we can think of a phone call signal as two people holding up a chain. Over long distances, the middle of the chain falls downward. As the chain drops, the signal connection gets worse and the call can disconnect. If more people were able to help hold up the chain, it wouldn't drop, which is where cell towers come in. Cell towers carry the signal, keep phone calls connected, and are crucial for the conversation audio to be exchanged. Wireless connection requires a transmitter and a receiver, which are located within our phones. As you can see in the picture, we can represent how phone calls work as a game of catch. The ball represents the electromagnetic spectrum that is passed around from phone to cell tower to the other phone. The person speaking has a voice with a specific frequency and wavelength. This is transmitted by the phone's antenna as an electromagnetic wave with a matched wavelength and frequency. This wave travels to the cell tower, which sends it to the other phone of the person listening. The second phone receiver decodes the electromagnetic wave into audio that allows for the message to be heard. This conversation happens instantaneously as a phone call because these waves travel at the speed of light, represented by the equation in the upper left of the figure. Wave interference can improve or disrupt wireless connection. Constructive interference occurs when two electromagnetic waves interact while in phase with each other, resulting in a stronger signal than before. Destructive interference, which is the out-of-phase interaction of waves, results in degraded or lost signal. An example of destructive interference is when two frequencies of radio stations are transmitting waves that interact destructively and result in static. This is a real-life example of electromagnetic waves when driving and receiving either clear or interrupted radio stations. These physics equations can be used to answer many useful questions, such as finding wavelength or frequency, since speed of light is constant, or finding distances of strong or weak signal depending on constructive or destructive interference, respectively. Technology is still changing and improving, and the modern attempt to connect smart devices is referred to as the Internet of Things. One example of IoT seen here is within smart appliances of our homes. Through wireless connection, devices can communicate through the cloud, allowing the several parts of one system to communicate with each other easily. The Harvard Business Review refers to this cloud connectivity as revolutionizing businesses, especially by giving companies the ability to perform predictive maintenance and therefore prolong product life. Overall, implementing physics into our everyday technology has improved sustainability and efficiency of our energy use.